Hello students, so today I will start with a new chapter, that is carbon and its compounds. Okay, so students, this chapter is slightly difficult, so I will upload a video also and I will conduct a live class also. So just before the live class I will upload a video, and I would recommend you to watch the video first and then attend the live class, so the things will become much clearer to you. And if you have any doubt, you can ask during the live class, and if you feel little bit shy or hesitant, then through WhatsApp also you can ask, but please pay attention. Okay, now I will give you the introduction about carbon. Same thing is given in the your NCERT book also, but here it is given little bit in detail. Actually it is same only. Now carbon is an element, you know, the symbol of carbon is C and it is a non-metal. Okay, now the name carbon is derived from a Latin word carbo. Carbo means coal. And why it is derived from carbo? Because carbon is the main constituent of coal. Here it's written carbon is the main constituent of coal. Okay, the amount of carbon present in the earth crust and atmosphere is very small. Not very, it's small, it's very small. For example, the earth crust contains only 0.02% carbon in the form of minerals like carbonates, coal and petroleum, and in the atmosphere it has 0.03% of carbon in the form of a carbon dioxide gas, that is in a combined form. In spite of this small amount of carbon available in nature, carbon element has an immense importance in every sphere of life. Carbon is a very important element. Okay, the importance of carbon can be gauged from the fact that we are ourselves made up of carbon compounds called organic compounds. Not we, living organisms like plants, animals, humans, they are actually made up of carbon compounds. How we are made up of carbon compounds? Our body is made up of carbohydrates. We have carbohydrates. Carbohydrates are the compounds of carbon. Proteins again are the compounds of carbon. Fats, compounds of carbon. Okay, what are compounds of, what do you mean by compounds of carbon? The compounds of carbon are the, what are compounds of carbon? What do you mean by that? Compounds of carbon are those compounds which contain carbon, that's okay, but the compounds of carbon are called as organic compounds. This I have explained to you before also. Now our body is made up of carbohydrates, starch, okay, or see here, C6H12, if I say O6, this is glucose. Okay, so what is this? It has carbon, so it is a organic compound. Protein, this is the CONH2, if you say here, amino acids. Okay, so compound, this, it has carbon, so these are the organic compounds. So what are the organic compounds? Organic compounds are those compounds which contain carbon, and our body of living organism generally is made up of organic compounds, that is the compounds of carbon. Carbohydrates, you know, starch, it's a organic compound. Proteins, fats and all, they are organic compounds. Understood? All the living organisms, plants, animals are made up of carbon based compounds which are called as organic compounds. You can see here, even these fruits, vegetables, most of the things are made up of carbon. See here, a large number of things which we use in our daily life are made up of carbon compounds. Our food material like grains, pulses, sugar, tea, coffee, fruits, vegetables are carbon compounds. The material like cotton, silk, wood, nylon, polyester, which are used for making clothes, are carbon compounds. The fuel like wood, coal, kerosene, LPG, CNG, natural gas, okay, petrol, diesel, which we use for cooking food and running vehicles, are carbon compounds. Paper, rubber, plastic, leather, drugs, dyes are also made up of carbon compounds. So it's clear that carbon element plays a very important role in our daily life. We can test the presence of carbon in a material on the basis of the fact that carbon and its compounds burn in air to give carbon dioxide gas, which turns lime water milky. Now if you want to know whether a particular material contains carbon or no, then what is done, that material is burnt, okay, and the gas is liberated, a smoke is liberated, and if that smoke is passed through lime water, and if lime water turns milky it shows that the given material consists of or contains carbon compound. Okay, because what is the test for carbon dioxide gas? Test for carbon dioxide gas is it turns lime water milky, and any carbon compound when it is burnt in oxygen always produces carbon dioxide gas. So if that gas is passed through lime water and if the lime water turns milky, shows that a particular material contains carbon compounds. Okay, now we come to carbon always forms a covalent bond. Now this one we will discuss slightly in detail. Now you can see here, students, carbon, this is the atomic number of carbon. It has electronic configuration of 2 and 4. Now but it is unstable because here in the second shell there should be 8 electrons, but here there are 4 electrons. And carbon, it belongs to what is the period number of carbon? Second period, because there are 2 shells. Okay, and what is the group number? Just add 10 here, the group number. In 4 you add 10, you will get 14. So the group number is 14, means here it has 4 valence electrons. Now in order to attain an inert gas configuration or a noble structure or a stable structure, carbon can either lose 4 electrons and become C4 plus, or carbon can gain 4 electron and become anion. Okay, but carbon neither loses electrons nor it gains electrons. Carbon does not lose electron because the size of the carbon is small. Okay, let us say this is first shell, this is second shell. So here there are 4 electrons. Now because the size is small, these electrons are under the attraction of, or this nucleus here, suppose if this is nucleus, this nucleus attracts the electrons strongly. So it is slightly difficult to lose the electrons, and if it happens also, then lot of energy is required. So this is not possible. Even C4 negative also, the formation of C4 negative is also not possible because the nucleus cannot hold 10 electrons. Okay, 2 here and 4 more will come, 10 electrons. So now what carbon does? Carbon has, I will show only the valence electrons. Carbon has these 4 valence electrons, and carbon shares these 4 valence electron with its own carbon atom or with the atoms of other elements, and sharing of electrons give rise to covalent bond. Covalent bond. What are ionic bonds? I have discussed with you ionic bonds. Ionic bonds are formed by loss and gain of electrons, and here one atom on losing the electron becomes positively charged and another one becomes negatively charged, and because of this the ions are formed, and these oppositely charged ions have a strong force of attraction. They combine and they form a compound which is called as ionic compound, like sodium chloride. Sodium chloride is an ionic compound because it is formed from sodium and chlorine. This all you know, I have already discussed with you. So this Na positive is positive ion or cation, and Cl negative is anion. So here this sodium gives its 1 electron to chlorine, and chlorine gains 1 electron from sodium, and both of them attain a noble gas configuration, and here the ions are formed. And now since they are oppositely charged ion, they attract each other strongly and they form a compound, that is NaCl, sodium chloride, common salt. Okay, and you know that the ionic compounds have very high melting and boiling point, and they are good conductors of electricity. Why they are good conductors of electricity? Because here ions are formed, and these ions, they carry electric current. Now now in sodium chloride, when water is added, what will happen? This is dissociated into Na plus and Cl negative, and it is this ions which carry the electric current, and sodium chloride is solid. So in order to convert it into a liquid state, what happens? There is a bond Na plus and there is a bond between these two. This is a ionic bond. Now in order to change its state, if it is present in solid, in order to change it into a liquid state, what happened? This bond has to be broken, and since this bond is very, very strong, so a high amount of heat is needed. So melting point is high. What is melting point? The temperature when a substance changes its state. So high amount of heat is needed to change its state. So therefore its melting point is high, and also the boiling point is also high of ionic compounds. Okay, but in case of this covalent compound, the boiling point and melting point is low, and they are not good conductors of electricity. Why they are not good conductors of electricity? Because ions are not formed. Actually it is the ions which carry the current. So here ions are not formed, so they are poor conductor of electricity, and melting and boiling point of covalent bond is low because the you can say the bond is not strong. The covalent bond which is formed is not strong. Suppose if this is A, this is B, and suppose this is the covalent bond, so this bond is not strong. So slightly on slight heating the bond can be broken and the state can be changed. Understood or no? Now see here in your NCERT books you can see this sorry, this you can see the melting and boiling point is not high. So students, before discussing the properties of carbon and its compounds, I would like to tell you about a covalent bond. What are covalent bonds and how they are formed? So some examples are given in your book also. Please see page number 60. Okay, so I will explain you those examples. Now just see here. This is hydrogen. One molecule of hydrogen which contains two atoms. This is one atom, this is another atom. The atomic number of hydrogen is 1. So in K shell there is 1 electron. Okay. Now you can see here, this is one hydrogen. This is another hydrogen. This hydrogen has 1 electron. This hydrogen also has 1 electron. But in the first shell there should be 2 electrons. In this hydrogen also there should be 2 electrons. Here also there should be 2 electrons. But the thing is this, from where to bring the electrons? They cannot bring from any market. There is no mall from where the electrons can be bought. So, but both the hydrogen needs 1 electron. So, this hydrogen says to this hydrogen that I'll share my electron with you. So, this hydrogen also says, okay, if you are ready to share your electron with me, I will also share my electron with you. So they both come to an agreement that both of them will share the electrons with each other. Now just pay attention. I am bringing it a little bit closer so that you understand it better. See, this hydrogen will share this electron with this. So which means this electron should come in the vicinity of this hydrogen. Okay, it should come in the area of this hydrogen. So you make a circle in this way that it comes in the area of this hydrogen. See here. Now you see this hydrogen has 2 electrons. Okay. Now students, this hydrogen shares this electron with this. So this hydrogen should come in the area of this hydrogen, or it should come in one circle. See here. See, circles are not coming perfectly, but you just understand first. See. So this electron and this electron has come in the vicinity or the area of this hydrogen. Now if you see this hydrogen, see, it will have 2 electrons. If you see this hydrogen, it also has 2 electrons. Okay, so like this, hydrogen and hydrogen electrons are shared, and now both the hydrogen has 2 electrons, and this bond is called as a covalent bond between 2 hydrogen is formed, and one line I have shown here because 1 electron is shared. Now when 1 electron is shared between the atoms, then it is called as single covalent bond. See here, it is called as single covalent bond. And just remember the atoms, whether it is 1 atom, whether 2, whether 3, they share the same number of electrons. Now we will see one more example of chlorine. You can see this is chlorine molecule, one chlorine molecule. It has two atoms. One is this and another one is this. The atomic number of chlorine is 17 and its electronic configuration is, in K shell there are 2 electrons, in L shell there are 8 electrons, in M shell there are 7 electrons. So it needs 1 electron to complete its outermost shell or to attain an inert noble gas or inert gas configuration. Now just I have drawn 2 chlorine atoms, one chlorine and another chlorine. Now in the valence shell there are 7 electrons. I told you we always show the valence shells. So 1, 2, 3, 4, 5, 6, 7. The electron which is shared generally, just for the sake of simplicity and convenience, just keep it in the middle. So now this chlorine also has 7 electrons. 1, 2, 3, 4, 5, 6, 7. But this chlorine needs 1 electron to complete its outermost shell. So this chlorine also needs 1 electron to complete its outermost shell. So both the chlorines share their electrons. This chlorine, if will share its electron with this chlorine, then its outermost orbit will be complete. And if this chlorine will share its electron with this chlorine, then its outermost orbit will be complete. So now this chlorine, I am just bringing it very closer to the diagram. This chlorine will share its electron with this chlorine. Means this chlorine will now go in the area of this also. So you have to make a circle in this way that it comes in the area of this chlorine. Okay. Like this. Now see, in this chlorine now there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now this chlorine also shares this electron with this. Sorry, this chlorine shares its electron with this. So now this electron should come in the vicinity of the other. See here. Now see, this chlorine is also having 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So students, just remember, this chlorine, when it will share its electron with this chlorine, then this electron should come under the vicinity of this chlorine. And when this chlorine will share this electron with this, so obviously it should come under the area or the vicinity of this chlorine. Okay. Now let us check. Now this is this chlorine. Now you see, only in this circle, 1, 2, 3, 4, 5, 6, 7, 8. And now you see only in this circle. In this circle also there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. So both the chlorines, now their last shell, valence shell is filled. And both the chlorines have shared 1 electron. So there is a single covalent bond. Okay, I hope it is clear to everyone. Bond. Now we will take the example of oxygen. Please see in your books. Okay, you just see here first. Now how this oxygen molecule is formed? Oxygen atomic number is 8. Electronic configuration is 2, 6. If this is O2, this is O plus O. 6 means it needs 2 electrons. Okay. So here sharing of electrons will take place. Now this is one oxygen and the valence electron of oxygen is 6. This is 1, 2, 3, 4 and 5, 6. Okay, it needs 2 electrons, so it will share its 2 electrons. Both will share its 2 electrons. See here, this is another oxygen. This is another oxygen, and here again it also has 6 electrons. 1, 2, 3, 4, 5, 6. Now this oxygen will share its 2 electrons with this. That means these 2 electrons will go in the area of oxygen. So you do it like this. Understood? Now this oxygen will also share its 2 electrons with this oxygen. Means these 2 oxygen should go in the area of this oxygen. So what you do? You like this you do. Understood? Now if I take the area of only this oxygen, see 1, 2, 3, 4, 5, 6, 7, 8. And if I take the area of only this oxygen, then again 1, 2, 3, 4, 5, 6, 7, 8. Okay, and what you will get? Oxygen and oxygen. How many electrons I shared? This oxygen also shares 2 electrons. this oxygen also shares 2 electrons. So now there will be double bond, and this is called as double covalent bond. Is it clear or no? I hope it's clear to everyone. Now we will discuss how nitrogen is formed. This is nitrogen. Atomic number of nitrogen is 7. Electronic configuration is 2, 5. And nitrogen means N and N. Okay, means there are N plus N. So it needs 3 electrons. So here also sharing will take place. Now let us see how. This is nitrogen. So in the last shell, how many electrons are there? 5. 1, 2. How many electrons it needs? It needs 3 electrons. So it will share 3 electrons. Just remember that it will share 3 electrons. So please make these 3 electrons here. Okay. Now this is another nitrogen. It will also have 5 electrons. 1, 2, 3. Now this nitrogen needs 3 electrons. So this nitrogen will share its 3 electrons with this. This nitrogen also needs 3 electrons. So this nitrogen will share these 3 electrons with this. So let me say this nitrogen is sharing these 3 electrons with this nitrogen. So these 3 nitrogen will come in the area of this nitrogen. Okay, now see 1, 2, 3, 4, 5, 6, 7, 8. Now this nitrogen will also share its 3 electron with this nitrogen. So it will come in the area of other nitrogen. Just do it like this. Now you see 1, 2, 3, 4, 5, 6, 7, 8. Now if you take only the area of the second nitrogen, it will have 8 electrons. If you take the area of only first nitrogen, it will have 3 electrons. And here nitrogen and nitrogen, how many electrons are shared by both the nitrogen? 1, 2, 3, 1, 2, 3. So there will be a triple bond, and it is called as triple covalent bond. Is it clear? Now see how water is formed. See all of you. In water there are 2 hydrogen and 1 oxygen. So hydrogen atomic number is 1, oxygen atomic number is 6. So the electronic configuration of hydrogen is what? 1, and here it is, atomic number of oxygen is 8. It is 2 and 6. So these 2 hydrogen needs 1 and 1 electron, and oxygen needs 2 electrons. So oxygen will share its electron with these 2 hydrogen, and hydrogen will share 1 electron with this oxygen. This hydrogen will share 1 electron with this oxygen. So it needs 2 electrons, and it will get these 2 electrons from these 2 hydrogen by sharing with its electrons. It's very easy. I will just show you this. Now here what you do, these things students you will know only by practicing. There are 6 valence electrons, 1, 2, 3, 4, 5, 6. So this electron will be shared by this hydrogen. This electron will be shared by other hydrogen. This is one hydrogen. Let me say this is one hydrogen. This is the electron of this hydrogen. This is another hydrogen. This is the electron of this hydrogen. Now this hydrogen shares its electron with this hydrogen. Understood? Oxygen. This hydrogen shares its electron with this oxygen. This hydrogen also shares its electron with this oxygen. So don't you think both the electron of both the hydrogen should come in the area of oxygen? See, circle is not becoming perfectly, but you have to understand. Now count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has got 8 electrons. Now this oxygen will share its 1 electron with this hydrogen. Okay. So you have to bring this electron in the area of this oxygen. This hydrogen. Now if you take only this area, it will have 2 electrons. Same way, this oxygen is sharing this electron with this hydrogen. See. So the compound form is oxygen, hydrogen, hydrogen. This is the structure of water. And here 1 electron is shared by all the 3. So there is a single covalent bond. I hope it is clear to everyone nicely. Now I will tell you the last structure of carbon dioxide. Last, and then let me see, also of ammonia also I will tell you. Now how carbon dioxide is formed? It's very easy. CO2. Carbon has atomic number 6. Its electronic configuration is 2 and 4. Oxygen has 8 and its electronic configuration is 2 and 6. Okay, understood? There are 2 oxygen atoms. It needs 4 electrons. So it will, both the oxygen will share 2 electrons with this carbon and carbon will share with this oxygen. See, I will show you. This is carbon. Okay. Now oxygen needs 2 electrons. There are 2 oxygen. Let me say this is 1 oxygen and this is 1 oxygen. Now this oxygen needs 2 electrons. This oxygen also needs 2 electrons. Okay, so carbon will share its 2 electron with this oxygen. Carbon will share its 2 electron with this oxygen. And this carbon needs 4 electron. So 2 electrons of this oxygen will be shared with this carbon and 2 will be shared with this. It's just see here. It's very easy. How many valence electrons do oxygen has? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Understood? Now this carbon has how many valence electron? 4. 1, 2, 1, 2. Understood? Now see here. This carbon will share its 2 valence electron with this oxygen. So that means these 2 electrons should come in the area of this oxygen. Now see, 1, 2, 3, 4, 5, 6, 7, 8. Here again it will share its 2 electron with this oxygen. So these 2 electrons of carbon should come in the area of this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Now this oxygen will share its 2 electrons with this carbon. This oxygen will also share its 2 electron with this carbon. So don't you think that these 2 electrons of this oxygen and 2 electrons of this oxygen should come in the area of carbon? See here. Now 1, 2, 3, 4, 5, 6, 7, 8. And here this is how it is formed. And how many electrons are shared by all the 3? 2. So this is the structure of CO2. There is a double covalent bond. How is ammonia formed? Ammonia atomic number is 5, electronic 7, electronic configuration is 2 and 5, hydrogen it is 1. And there are how many hydrogen? There are 3 hydrogen. So it needs 3 electrons. So these 3 hydrogen will share its 3 electrons with this nitrogen and nitrogen will share its electrons with this. See here how. This is nitrogen. This is 1 electron, 2 electron. Okay. And these are, sorry, in the valence, I am not this one. We always show the valence electrons. So 2 electrons are this. How many are left? 3. 1, 2, 1, 2, 3. How many hydrogen are there? 3 hydrogen are there or no? So this is 1 hydrogen, 1 electron, another hydrogen, another electron, hydrogen, another electron. So now this hydrogen shares this electron with this nitrogen. So this and this hydrogen also shares this electron with this nitrogen. This hydrogen is also sharing its electron with this nitrogen. So don't you think that all these electrons of hydrogen should come in the area of nitrogen? So what you do, just include it in the area of, see here. Now count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now this nitrogen will share its electron with this hydrogen. So it should come in the area of hydrogen. This nitrogen will also share its electron with this hydrogen. So it should come in the area of this hydrogen, and same here also. Now you see in this area, this is the area of hydrogen, 2 electrons. This is the area of this hydrogen, there are 2 electrons. This is the area of this hydrogen, 2 electrons. Understood? And this is the area of this nitrogen. You count the number of electrons, there are 8 electrons. So students, please practice the structures. Okay, then only you will understand, then only you will be able to do this thing. I have told you number of times in your offline classes, even in the live classes also. Please practice these structures. Whatever I have discussed with you, try to practice on your own. You will not be able to do otherwise. Okay, and now in the next class I will start with carbon. Okay, thank you students, have a nice